Good afternoon for all of you. I hope you are fine, you and your family. Please stay at home and be careful. Today, inshallah, we will start to complete the lessons we start in the class. We will move on the syllabus. With you, Mr. Mostafa Ibrahim from Tabarak Private School.
Assalamu alaikum wa rahmatullahi wa barakatuh. In this video we will take the last lesson in chapter 3. The last point in chapter 3 about buffer solutions. Firstly, we want to know what is meant by buffer, what is buffer solution, and how does it work, and how to calculate pH. So 3 points. What is buffer solution, how does it work, and calculations of pH of buffer solution. Firstly, what is meant by buffer solution? Buffers solutions, they resist the change in pH. What is meant by buffer solution? Buffer solution, it resists the change in pH when a small amount of strong acid or base is added to it. How? When we add strong acid to a solution, the pH must decrease, but when it is added to a buffer, it decreases by very small change. And also when I add strong base, the pH must decrease, must increase. But when I add it to a buffer, it resists the change in pH. So buffers, they resist the changes in pH when a small amount of a strong acid or base is added to it. Generally we have two types of buffers, acidic and basic buffers. Firstly, acidic buffers. What are acidic buffers? Acidic buffers are formed by mixing weak acid and one of its salts. Again, weak acid and one of its salt. Weak acid like CH3COOH. How it is I make its salt? It's a salt by remove H and replace it by strong metal from strong alkali like Na, like K, like Ni. So I can make a buffer from weak acid and one of its salts like CH3COOH and CH3COONA. Also like HF it is weak acid, and KF or HF with NaF. I remove H and add instead of it Na or K. How does it works, acidic buffer? Let's see. When I asked you, when I add a small amount of acid H positive or a small amount of base OH negative, how does the buffer will work, or how does the buffer solution resist the change in pH? Most of these questions explain by chemical equations, so you will explain by write the equations. So the first equation you write, remember the buffer is what and what? CH3COOH and CH3COONA. So the first two equations, the dissociation of these two, the weak acid CH3COOH, its dissociation is very easy, CH3COO negative plus H positive, and don't forget it is a weak acid, so reversible arrows, reversible reaction, but the salt completely or fully dissociated, so one arrow it gives CH3COO negative and Na positive. So when I asked you what will happen when I add H, or what will happen when I add OH, when we add hydrogen ions, يعني we add an acid, what will happen? The negative part, which is written in red, will react with H positive to give what? To give the acid. So we do what? Now we remove most of hydrogen added, so it will resist the change in pH. But when we add OH negative, what will happen? The acid, which is ethanoic acid, will react with OH negative, gives CH3COO negative plus H2O. So it removes most of OH added, so it resists the change in pH value. Now the second type, basic buffers. Basic buffers, it contains also, it is a mixture, not one substance. Buffer, it is not one substance, it is a mixture in acidic, weak acid with one of its salt. In basic buffers, weak base and one of its salts. Weak base like NH3. Some students ask, how can I know it is weak or strong? Revise the lesson of strong acids and strong bases in acid base equilibrium video. You will find the strong acids and the strong bases. NH3, it is a weak base, and NH4Cl. How can I write the salt of the base in acids? Remember, you remove H and add Na or K or Li. But in bases, how can you write the salt of it? You add H and another part from strong acid like Cl or Br or I. So NH3, its salt will be what? NH4Cl. Another weak base, N2H4. Its salt will be what? The base N2H4. So its salt will be N2H5Br or Cl. So when I asked you explain by using equations how the basic buffer resists the change in pH value, firstly you write the two equations, the dissociation of base and its salt. Dissociation of base, weak bases, we take it before in Kb. NH3 plus H2O, you add H to the base plus OH negative. So NH3 plus H2O gives NH4 positive plus OH negative. And the second equation, NH4Cl, divided into NH4 positive and Cl negative. And don't forget the first equation of weak base or weak acid, reversible arrows. The second equation, one arrow, irreversible, because it is completely dissociated in solution. And when we add acid or base, what will happen? When we add acid, the base will react with it. When we add acidic medium, yani we add H positive, so NH3, the base, will react with H positive to give NH4 positive. If I change this base, I write CH3NH2. So CH3NH2, it reacts with H to give CH3NH3 positive. And if I add OH negative, the positive part from the salt will react with it. NH4 positive with OH negative gives NH3 and H2O. So when I add H positive or OH negative, we remove most of them added, so we resist the change in pH value. After that, what are the buffer calculations? How can I calculate pH for buffer solutions? We have more than one method to calculate pH for buffer solution, but Henderson-Hassel-Balch equation is the easiest equation. How can I calculate pH in acidic buffer? pH equals pKa plus log A negative, the negative part from the salt, divided by the concentration of the acid. So you can write log the concentration of salt over the concentration of acid, and pOH in basic buffers equals BKB plus log the salt over the base, salt over the base. But some students ask, when I calculate pOH in basic buffers and he asked to calculate pH, how can I calculate? You know another rule, pH plus pOH equals what? 14. So after you find pOH from basic buffers, you can find pH from the equation pH 14 minus pOH. Let's see this example. We have to calculate, or we want to calculate, pH of a buffer solution made of 0.2 C2H3O2 and 0.5 of C2H3O2 negative, this the salt, and we give you Ka. But we said the rule pH pKa plus log the salt, or the negative part, if divided by the acid. But we don't have pKa, we have what? Dissociation constant, acid dissociation constant. It is what? Ka. So I can find pKa, the first point. It's very easy, negative log Ka. So I can find pKa, negative log Ka. So negative log 1.8 times 10 to the power negative 5 plus log the concentration of salt, the negative part 0.5, divided by the concentration of acid is given 0.2. So if you know the rule, you know the formula, it will be very easy for you to find pKa from negative log Ka. Then plus log the salt divided by acid. The concentration of salt 0.5 divided by 0.2. So it will be log 2.5. So by your calculator you will find pH 4.7 plus 0.40. So the final answer will be 5.1. By this lesson we finished the chapter 3 of equilibrium. So please, I said before, write all these notes in your notebook and revise them carefully. You will find homeworks related to these videos. Good luck for all students. I hope you understand the lesson. Thank you for listening and goodbye.
I hope you are enjoy the listening and you understand the topic we explained today. We appreciate the efforts of Mr. Yunus Rahbi, the chairman of Tabarak Private Schools Group, and don't forget your homework is uploaded on Moodle on Tabarak Private School site. Thank you and goodbye.